A function is a relationship that pairs each input with exactly one output. The inputs are called the domain of the function, and the outputs are called the range. Functions in math are often notated in the form f of x. The f is the function name, like a variable, and the x inside is the input. Each input in a function can only have one output. If there are two outputs for a single input, that's a relationship and no longer a function. Think of a function like a vending machine. When you put something in, it will give you the same result. For example, if the function is f of x equals x plus 5 when you put in x equals 2, the machine will give you 7. Plug in 2 again and you still get 7, not 8 or 9 or anything else. If it's a true function, you should always get one consistent result. One way to check if something is a function is using a graph. The x-axis represents the inputs, and the y-axis represents the output. To determine whether or not the graph is a function, we can use a vertical line. If a vertical line touches only one point on all inputs of the graph, then it's a function, since this means that each input only has one output. So is this line a function, x equals 5? Well, yes, because no matter where we draw a vertical line, it only crosses the function at one point. Now, is the graph of a circle a function? No. Place a vertical line anywhere in the middle, and we see that it crosses the circle at 2 points. So this is a relationship, not a function. Now, remember earlier when we mentioned the domain and the range? Well, the domain tells us what inputs you can put into the function. Is it a real number, an integer? What value is it between? Similarly, the range tells you the range of the outputs. This answers the same exact questions as the domain. What kind of outputs are they, and what values are they between? Okay, the symbols can be confusing, so let's see what this means. Let's say we have this function, f of x. Here, the domain of f of x is a real number greater than or equal to 0 and smaller than or equal to 4. So what is the range of f of x? Since this is on an xy plane, all the numbers must be real. And what numbers are the outputs between? Well, at 1, f of x reaches a maximum at 2. This is the greatest point on the function. And at 0, f of x hits a minimum with a value of 0. This is the lowest point on the function. The range tells us what values the output must be in between. So the range of f of x for the inputs in our domain will be greater than or equal to 0, but less than or equal to 2. As you can see, the domain and range tells us what a function covers, since not all functions cover every number. And this is very useful to know. For example, take this function, the square root of x. This function is true for any positive number. However, negative numbers aren't in the domain of the function, since it requires real numbers. So this function cannot have any negative numbers, and we know this to be true. The square root of any negative number is imaginary. Another example of the importance of domain and range is the function 1 over x. This function, g of x, has a domain of any real number other than 0. If you try inputting 0, you get 1 over 0, which is undefined. So when using functions, it is important to make sure you are keeping everything within the domain and range. Now, why are functions useful? Functions can help make predicting things a lot easier. For example, take a look at this function, w of t. Let's say this function represents the gallons of water in a tank, where the input, t, represents the time after the drain is open. How much water will be in the tank 10 minutes after the drain is opened? Well, just plug in the input, 10. Doing this, you get negative 40 plus 200, or 160 gallons. So 10 minutes after draining, there will be 160 gallons in the tank. Now, here's another question. How long until the tank is empty? Well, in this example, instead of solving for the output, we're looking for the input, t. To avoid confusion with the original function, let's use a separate variable to represent this, n. N represents the time when the tank has 0 gallons, so w of n would be 0. Thus, we have 0 equals negative 4n plus 200. And to solve, we can add 4n to both sides and divide by 4, and we see that 50 minutes after, the tank will be empty. Now, as a bonus question, what is the domain and range of this function? Well, since the input t is only measured after the drain is opened, the domain has to be greater than or equal to 0. But once there's no more water in the tank, no more water can drain out, so the domain has to be less than or equal to 50. Now, what would the range be? We know that the water is constantly draining out, none is being added in. So at time 0, before the drain is let out, that's when there must be the most water. W of 0 is 200. So the output must be smaller than or equal to 200. Where there's no more water, the output is at a minimum. So the range is greater than or equal to 0 and smaller than or equal to 200. Bingo. And plotting this function on a graph, we can verify our answer. And that's all about the function. It's a simple, useful building block in math that lays the foundation of calculus and so much more. And now you know what it is. Also, you probably know that you should like and subscribe, and share this video with a friend who's confused about math. These videos take hours and hours to make, so if you enjoyed this or learned something useful, you can support the channel by subscribing. Now, keep working hard and keep learning. Thank you for watching.